Okay, well that's why we check it. So I had to go back and take a look at the video. So here's the matrix, 4, 0, 1, 10, 1, 4, 0, 2, 3. That all looks good. But I'm pretty sure when I did that, all I did was say math fraction, and it gave me the previous answer. So let's just type it in again. I need math, row echelon form of matrix A, and check that out again here. Okay, there we have it. Now I'll go math fraction. So everything was in right, just didn't push all the buttons. So there it is. So let me adjust what we have here. It's 0, 1, 1/4. So right here was 1/4. If I have a different color here real quick. Oh well, we'll have to deal with it. So that was 1/4. And then the other one was 3/2. So this was a 3/2. So this part was B plus 3/2 equals C. And this part was A plus 1/4 equals C. So our A term, when I move the A over here, that will be negative 1/4 C. Moving the B term over here, that will be negative 3/2 C and then C. Now, just as an observation, these negatives are just saying that these two things are on the opposite side of the balance bar of this one. So these two are on the opposite side of this one, which makes sense. They're over here and the C term is over here. Okay, so now instead I'll just make C 4. Okay, if C is 4, here we had the 2, that'll make this a negative 6, and that'll make this a negative 1, and now we want the absolute values of all of those. So our actual answer should have been 1 P4O10, 6 waters, and then that will give us 4 of these H3PO4s. Now let's test it out. Let's take a look at this potassium. There's 4 once, so that's 4 of them, and none here. So the potassium on this side is actually 4. There's 1 potassium 4 times. So now our potassium is 4 and 4. So the potassium is balanced. What about oxygen? There's 10 once, and there's 1 6 times. So I've got 10 of them from here and 6 of them from there. So this side looks like has 16, and there's 4 of them happening 4 times. So the oxygens are also balanced at 16. And now the hydrogens. Okay, there's 2 6 times, so there's 12 of them over here. And there's 3 4 times, so there's 12 of them over here. So here's our balance set, and here's the balanced equation. Okay, let's take a look at number 16. So it looks like I've got, that's a lowercase l, so that's AL. Not sure what that, maybe that's aluminum, but I'm not sure. Okay, so there's 1 of them here. That 3 is just for those. So there's 1 there, there's none of them there, there's 2 of them here, and there's none of them here. Then I've got oxygen. There's a set of 3. There's 4. There's 4 3 times, so that's 12, and there's 1 more. Now this would be hard to do by hand. If I've got 12 of them on this side and 13 to do on that side, that looks like a difficult one to do by hand. Hydrogens, here's 3. Here's 2. So this side has 5. Hydrogens, there's none there, and there's 2 there. So I got a 12 against 13 oxygens and a 5 against 2 hydrogens. That's not a simple balance. Sulfur, no sulfur, 1 sulfur, 3 sulfurs, and no sulfurs. Okay, do we have anything else? HOSAL. So I've got a 4 by 1, 2, 3, 4. Let's type that one in. This time, so I've got a 4 by 4. 1, 0, 2, 0, 3, 4, 12, 1, 3, 2, 0, 2, 0, 1, 3, 0. Get the reduced of that one. Okay, so everything is good. We've got the bottom row dropping out. So it's 1/3, 1/2, negative 1/6. So we've got 1, 0, 0, 1/3. I've got 0, 1, 0, 1/2. And we have 0, 0, 1, negative 1/6. So A, B, C, D. Here's a relationship right there. C minus 1/6 D. Here's B with D, so B plus 1/2 D. And here I have A plus 1/3 D. So my relationship then is A, if I move the D to the other side, is negative 1/3 D. B will be negative 1/2 D. Move this to the other side will be 1/6 D and D. So see how these two are positive, they're on the same side, that's representing those two, and these two are negative, that's representing the other side. So it looks like if I just make D6, that's 1/6 times 6 will make this one a 1. negative 1/2 times 6 will make that a negative 3, and this one a negative 2, but we want the absolute values of those. Okay, so this one gets 2. There's 3 of these. There's 3 of these. Oh no, there's 1 of these, that was a 1. And then there's 6 of waters. Okay, so let's make sure it balances. AL over here, there's 2. And right there's 1 package of this, so there's 1 of these sets of 2. So it's 2 and 2. The oxygen, okay, there's 2. First of all, there's a set of 3 of them right there, but then there's 2 of them, so that's 6. And then there's 4 at a set of 3, so that's 12. So we've got 6 and 12. So there's 18 oxygens over there. Okay, there's 12 oxygens and 6 singles. So there's 12 and 6 for 18 over there. So things are going well. Hydrogen. Okay, there's 3 of them twice. That's 6. And there's 2 of them 3 times. So I've got 6 and 6 for 12 of those. Hydrogens, there's 12 and none there. So hydrogens are good. And sulfurs, none there. So I've got 3 singles, so that's 3. And here we've got a package of 3, so that's 3. So the sulfurs are 3 against 3. So there's the set of elements, and here's the balance.